So this video is about the ordinary differential equation of first order. So this is an introduction video. You can say that this is the first video in which I will be sharing a methodology for solution of ordinary differential equation of first order. And the second thing which I will be talking about is how to find order of a differential equation, whether it's a first order or second order, or whether it's a linear differential equation or not. So this is a first video or lecture 1. So a prerequisite to solving ordinary differential equation is having some knowledge of differentiation, and this is ordinary differential equation are usually as part of advanced mathematics or engineering mathematics, etc., which is taught as part of some of the curriculums in schools, colleges, etc. So a differential equation in which the unknown variable is single, or differential equations dealing with unknown variable is equal to only one unknown variable, is known as ordinary differential equation, unlike the partial differential equation which will deal with two or more unknown variables, while the ordinary differential equations will deal with only one kind of unknown variable. And these are mostly used to model the or to produce model for mathematical models of engineering equipments or engineering phenomena. So this is used to produce ordinary differential equations are used to produce the model. So suppose there would be equation y is equal to e raised to x. So this equation, so the y is a function which is dealing with, or xt if it is. So how is the decay of the variable x is happening as the time is going on? So these are a little bit tricky to understand, but one thing you need to know is that if there is a variable or a function which can be given by y is equal to e raised to x, so if you'll find dy by dx of this, it will be equal to e raised to x itself. So just taking an example of how to find a solution of ordinary differential equation. So it can be written as dy by dx is equal to y, and when you are having such a case, if you want to find dy by y is equal to y dx, or dy by y is equal to dx. So what is your x, or how to find your x is equal to integration of one upon y dy. So when you are doing integration of this, what you will get is ln of y plus c is equal to what is your x. So ln of y is equal to your x minus c. So e raised to y can be written as e raised to x minus c. So e raised to y is equal to e raised to x into e raised to c. So if you are integrating, or your y is equal to e raised to uh, x into e raised to minus c. So if you are taking this, y is equal to a into e raised to x is a general solution of this equation. So for this is what is my ordinary differential equation, and this is what is my first order ordinary differential equation. And what I have got by solving this, so the method of solving an ordinary differential equation, this is an ordinary differential equation because the unknown variable is only one here, and the unknown variable is what is my y here. So there is only one unknown variable, and you are separating it and integrating it with respect to the unknown variable to find out what is my general solution. So for each x there will be a different solution here. So this could be a graph in this way or this way based on which way my x is going. But when you are putting an initial value like x equal to 0, if you're starting from x equal to 0, you'll get y of 0 is equal to a in this case, because e of 0 is equal to 1 and y of 0 is equal to a. So this equation will become y is equal to y naught e raised to x. What this is known as is, this is one of my specific solution for this equation. Or particular solution. So again, so this again, it's what we talked about was equation in the form of dy by dx is equal to 1y. This equation can be termed as an ordinary differential equation, and this is just an example of ordinary differential equation, and we saw how to solve this. Again, if you have an equation in such that dy by dx is equal to x square, this is a first order ordinary differential equation. Again, this is a first order, and both of these are linear equation. Now if I have an equation like dy square divided by dx square, which is equal to x square, then this can be written as y double dash minus x square is equal to 0. Since the power is of the differentiation is 2 here, or the power of the differentiation is 2 here, this is a second order differential equation, and this is a second order linear equation. But if I have an equation like this where dy squared divided by dx square is equal to x square plus y square, here the power of the unknown or the variable to which I am differentiating, or the function which I am differentiating with respect to x, is 2. So this is a second order non-linear differential equation. And again, if I am having an equation like dy by dx plus y square equal to 0, so this is a first order non-linear equation. So these are the different kinds of, these are how to find out whether it's a first order equation, or how to find whether this is a second order equation and whether it's a linear equation or not. So in this chapter what we will be talking about is, we will be talking about ordinary differential equation of first order, and how to find a general solution and particular solution for those.